Hi, my name is Jiayuan Fu. I am an AI researcher at Ramin AI. On this session, I'm going to talk about machine learning time series forecasting. Okay, this is the outline of my talk. First, I will explain why forecasting is important for business. Then I will spend a bit of time diving into the machine learning forecasting methodology and forecast performance on the output section. Furthermore, an example of how to run time series forecasting on Amazon Forecast will be demonstrated. First of all, what is forecasting? Forecasting is a technique that uses past and present data as input to make informed estimates and predict the future. It can be used for setting up sales APIs. It also can be applied for supply chain management, promotion planning, and other business decisions for executive leadership teams. Moving on, when we talk about forecasting in general, there are basically two types of challenges. As shown below, this is an example of a product sales. The green area represents the actual sales, and the yellow line represents the forecast. If we forecast too low, like the left side of the graph, we may lose sales and also lead to disappointed customers. On the other side, if we forecast too high, then probably we will have too much product stays in the warehouse, which leads to wasted capital. Therefore, it's important to have an accurate forecast because it has a direct impact on business. Time series forecasting is not a new topic. Prior to recent innovation in machine learning, time series forecasting was primarily structured around univariate forecasting, which means the model was only able to consider historical demand data as input. Additionally, the algorithm used in the past was mostly statistical models, such as the Riemann and Profit. This type of models has two limitations. First, most of them are based on strong structural assumptions, which means they only consider trend and seasonality patterns as priority. In a real-world scenario, if there is a new product that haven't sold in the past, or if there's a random promotion, the model are not prepared to handle this type of situations. Secondly, they can only have a single output, and that is a forecast. There's no any ways to describe how certain the forecast is. On the other side, recent innovation in machine learning forecasting allows model to ingest multiple time series data as input, such as promotion, price, and similar skills demand. It's very helpful for capturing random spikes and handling co-star situations. The modern approach also involves multiple deep learning methods and probabilistic methods to improve the accuracy. As a consequence, the result conveys uncertainty and offers a range of forecasts. To sum up, these are the differences between the two approaches mentioned above. For the input data, the old approach only used the past demand as input. However, the modern approach is able to add multiple time series, such as promotion, similar skill demand, and product pricing. The old approaches uses statistical model for training and forecasting. The promotions are only applied as a modifier in this case, while the modern approach involves AutoML, which includes both deep learning models and probabilistic models. For the forecast, the modern approach carries more probabilistic information instead of a single output. It also has the advantage of being able to run forecasting on new products and capturing random spikes. This is an example of the three types of dataset which can be used for forecasting. As a highlight in the middle, the three types of datasets are target time series dataset, related time series dataset, and item metadata. The target time series dataset is a historical demand data, which used to predict future values. The related time series dataset includes all the other time series data which may impact the target value, such as price, promotion, weather, COVID, and special events. The item metadata is the categorical data that provide more context about items. The combination of these three datasets provide the input data for modeling. After we prepare the input, this data will be trained on a list of models. The AutoML methodology will be used to choose the best model to generate the final forecast. As shown below, the AutoML layer contains three parts. They are the multivariate data, training models, and production models. During the training process, each training model will be tested with the multivariate data and generate the independent accuracy for that model. After the training process finished, the model which has the best accuracy will be selected as a winning model to be used in production. The final forecast will be generated based on this production model. Okay, now we already have the input data and the machine learning production model. It's time to have a look at the output. There are two graphs in this sample result. The first graph shows the forecast result from a neural network model, and the second one presents the result from a statistical model with a holiday modifier. Imagine if this sample data represent the real sales of a specific product in a store in a certain country. For example, it can be a chocolate bar which sells in a store in China. There are many factors can affect the sales volume. For instance, the brand, the size, the flavor, the price are essential. There is another feature which is even more important, that is the holiday. For example, the sales volume of the chocolate on Mother's Day or the National Day should be much higher than a normal weekday. Let's back to the graphs. As we can see, for both of them, the y-axis indicates the sales volume, and the x-axis specifies the time frame, which is from April 2017 to June 2020. Looking more carefully to the graph, you could see the actual sales is the gray line, and the blue line represents the exact forecast result. The blue area covers the confidence interval. You may already realize that both of the graphs has the same historical data, and the data from April 2017 to August 2019 is used as the training set. The test set is from September 2019 to June 2020. As you can see, there are some spikes from the historical data. For instance, October 2017, October 2018, and October 2019 has massive increase in sales because of a local public holiday. You may still remember that I mentioned there are three types of dataset can be used as input data for the deep learning model, which are target time series dataset, related time series dataset, and metadata. In the case of the first graph, the historical demand is a target time series. The holiday data is a related time series. The brand and category are considered as a metadata. However, for the second graph, there's only one type of data can be used as input, which is the historical demand. The reason is the statistical model can only take one time series as input. The holiday data can be only used as a modifier afterward. The result will be transformed into two parts. One is the exact forecast result, which is a blue line as we mentioned before. And the second part is the confidence interval, which presents into the blue area. The confidence interval is a very useful indicator to understand how certain is a forecast result. When the confidence interval is narrow, it means the model is more confident with the forecast result. On the other hand, if the confidence interval is wide, it means the forecast carries more uncertainty. Let's have a look on what happened for the forecast result from the second graph. As we can see, based on the effect of the holiday modifier, the forecast could capture the October spikes in 2019. However, the other forecast result after October 2019 looks like a slight increase trend plus a repeated monthly seasonal pattern on top of it. This is based on the reality of using a statistical model. In a real-world situation, most of the time, the sales will not be as perfect as the forecast result from a statistical model, which means the statistical forecast will have poor performance. Okay, let's move our attention back to the first graph. The forecast result from the first graph seems to be more irregular compared to the second graph. However, it brings more accurate forecast across the whole testing period. It's also able to capture more spikes compared to the graph below. One of the major reasons is there are multiple time series data and metadata are used as input features in order to generate a more accurate forecast result. Although most of the time, the forecast from the deep learning model has better accuracy compared to the statistic model, it still doesn't mean that we should just remove the statistical model from the engine. Actually, in production, there will be hundreds of products to forecast, or maybe even more. And each product will have a totally different character on the historical demand. A statistical model is still very useful for capturing the outliers. The graph shown below has a similar format with the previous ones. The y-axis is the sales volume, and the x-axis indicates the time frame. The blue line represents the actual sales, and the green line is the forecast value. The only difference is this graph has two confidence intervals, which are the 90% confidence interval in light green color and the 50% confidence interval in dark green color. The 90% confidence interval means of 90% of the time, the demand will be fall into the light green area. You can see in the graph that the actual demand, which is a blue line, only exceeds the light green areas once. Okay, I hope you already have a better understanding about what is machine learning time series forecasting. Now it's time to move on to the next section. I will list a couple of services which offered by AWS for running machine learning model time series forecasting. Then I will demonstrate how to use Amazon Forecast from AWS console. AWS offers a variety of services for modern machine learning forecasting. The most popular ones probably are Amazon Forecast and SageMaker. Amazon Forecast is a fully managed service that uses machine learning to deliver accurate time series forecasting. It has a selection of built-in machine learning models. It's easy to use and doesn't require much machine learning experiences. Amazon Forecast can be accessed from both API and AWS console. Later on, I will show a demo on how to use Amazon Forecast from the console. Amazon SageMaker is another fully managed service which allows data scientists to build, train, and deploy machine learning models quickly. SageMaker works for both built-in models and custom machine learning models. It's easy to deploy and has more flexibility on large-scale productions of machine learning forecasting models. Moving on, this is how Amazon Forecast works. Before jumping to Forecast, we need to have all the historical data and related data on hand and uploaded them to a S3 bucket. Then we need to open the console and follow the instructions to identify the attribute, the three types of dataset, and choose a machine learning model for forecasting. After the model is trained and optimized, the model accuracy is able to be reviewed before generating the forecast. Since the forecasting process is finished, the result can be visualized in the console or exported as a CSV file, or even can be retrieved by API and integrated into other applications. It's fairly simple. This is a demo of how to use Amazon Forecast from the console. First, you need to log into the console and search for Amazon Forecast from the AWS services. Then you will see this page. By clicking on Create Dataset Group, there will be a step-by-step instruction allowing you to choose the three types of datasets, identify the attribute, and choose a model. Then you will find this page. You are able to review the details of the input data, start training and forecasting, then review the result in console, or export the result as a CSV file, etc. Then that's it. It's fairly simple to use. To sum up, we have talked about the importance of having accurate forecast in business, followed by the explanation of the prior and reason methods. Then we went through a couple of example outputs and show how to run Amazon Forecast. I hope you enjoyed this talk, and thank you very much for joining us.